So in a circuit, the electricity flow from positive to negative, yeah?
from positive to negative.
Yeah, but in AC, it will flow from negative to positive, yeah?
No, no, it will flow from positive to negative in start, but it will change its direction from negative to positive also, right? So both direction will be possible in AC, but it will
Okay.
start from positive. Okay.
Okay.
So if we talk about our topic of diode, so basically diode is a device or a component which is made up of semiconductors, right?
What are conductors?
Semiconductors, we can say that they are not purely conductors by adding some impurities or some other elements with semiconductors, just like silicon and germanium are semiconductors. If we take the example with the name, so germanium, silicon, these are semiconductors, right? So by adding
Yes.
impurities, we can use them as a conductor. So basically, these are materials which we use in diodes. And the main purpose of discussing this topic is to discuss the function of the diode. What is the main purpose or the main function of diode using in our circuit? So if we talk about the main function, so we can use diode as a rectifier. So the important term or the important concept included in our syllabus is that diode can be used as a rectifier. Okay.
Yes.
So diode can be used as a rectifier. And what is the process of rectification? Let's see that what is the meaning of process rectification. So the process or the main concept of rectification is to convert AC into DC. So the main purpose of this process of rectification is to convert AC current, or you can say that alternate current, to direct current, right? And if we
Yes.
talk about the electrical symbol of diode, so electrical symbol of diode will be like this. So this is the electrical symbol of diode. So whenever you saw this diagram or this component in the circuit, so you can identify with this diagram that this component is known as diode, which is connected in a circuit, right?
Yes.
So now our main purpose is to convert AC into DC. So let's suppose if there is a circuit, again we consider a circuit over here. This is a positive, this is a negative end, right?
Yes.
And we connect our diode over here. This is a diode connected in the circuit, right?
Yes.
And now we connect AC supply over here, right?
Yes.
Not DC, because we are going to convert that AC into DC. So DC will be like the battery and AC will be like a wave type circular diagram, right? So basically this will represent you the AC supply. This is a
Yes.
symbol of wave which represents you that there will be an alternate current which is passing into the circuit, right?
Yes.
And let's suppose if there is a lamp connected over here. So there are two possibilities. Either we can connect this diode in the forward direction, or either we can connect this diode in backward direction, right?
Yes.
So in this diagram, the diode is connected in forward direction, right?
Yes.
So diode is connected in forward direction. And if we discuss about the forward direction, So the main purpose is to convert AC into DC. So we already know about the graph. Let's see if we draw a graph for AC. So graph for AC will be like this. This is the direction of time. This is the direction of electric current, both directions. So when this device will convert AC into DC, so the final graph will be like the graph of DC. You can see in the first diagram, there are both direction possible for electric current. One is forward, second one is backward, right?
Yes.
So if we talk about the final graph, which is, or you can say that which is going to be passed from this circuit, that AC current which is passing through the diode. So final diagram will be like this. It will cancel out one direction, or you can say that the backward direction. It will only allow forward direction because this diode is connected in a forward direction. So only forward current will flow in this circuit, right? So this
Yes.
lamp will light up, okay?
Hmm. Oh.
Because
So if
forward,
there is
yes,
if there is just an
yes,
AC connector, the lamp will light up.
yes, light lamp will also light up, but our lamp is connected, or the lamp which we are using in our circuit will operate on DC, right? Because we use a single supply in our components and in our devices. Let's suppose if we take example of a computer or any LED or a mobile phone or anything, so we just connect a single supply from our main supplies, right? So that main supply
Yes.
will give you a AC, right? So there are many components connected in the circuit. So not every component will work on DC or AC. Some components will operate on AC, some components will operate on DC. So wherever we are going to supply DC current, so we connect a diode, because from the basic we are receiving AC and we have to convert them into DC, right? So we just need
Yes.
to connect diode in the path of that circuit. Otherwise, AC is already flowing in the circuit, right? So that is the purpose of using diode. We will not supply individual power to each and every component connected in the circuit, right? We just use a diode to forward the electric current into the whole circuit, right?
Yes. And sir, and before you said that in AC the battery flows from negative to positive.
No, no, current will start flowing from positive, but after moving from positive to negative, it will also move in the backward direction. Charges will not flowing from the negative, but those charges which are moving from positive will return back towards positive in backward direction, right?
Yes.
Just like a
So
oscillator or a vibrator.
so there are charges from reflecting from negative to.
Yes, negative to positive.
Mm. So the lamp will get also the AC.
Yes, because the frequency of the current is very much high, so we are not able to observe that fluctuation in the AC because the frequency was very much high. So that's why that was not observable with our normal eyes, right?
Yes.
So if we consider another circuit in which the forward current is flowing into the circuit, let's suppose if there is again an AC supply over here and there is a diode connected over here. So diode is also connected over here, and there is a lamp again connected on the right hand side. Okay, now we need to connect this diode in reverse order now, right?
Yes.
So this is the reverse direction of the diode. So now the graph, or you can simple words, we can say that there will be no current flowing in the forward direction, right?
Yes.
So there is no forward current flowing into the circuit. So it means that the lamp will remain off in this situation, right?
Yes.
So this can also be done with the help of a diode, that if we are going to use reverse direction of current or reverse biasing, there is a term which is known as biasing. So either we use forward biasing or the forward direction of diode, or either we use reverse biasing, or you can say that the reverse direction of the diode, right?
Yeah, but what happens in the AC? The AC, there are some the electrons flowing from negative terminal, yeah?
Yes. So
So why
because
why don't they affect on the lamp?
it will affect on the lamp, because it only requires charges, right? So
Yes,
I already mentioned that some devices will operate on AC, some will operate on DC, right?
yes,
So that's why we need to check first that either this device will operate on AC or DC, because you observe that some of the lamps will work directly from the main supply. So that means they are operating on AC, and some have batteries built in there. So it means that they will operate on DC, right? And their battery will charge from AC, right?
yes,
So that is the difference. So the main purpose of diode is to convert AC into DC, right?
yes.
So this is the main purpose of AC, or you can say that a simple diode. And there are some other example of diode as well. There are LEDs which we use in our normal circuit. There are LDRs, detecting resistors, or there are thermistors which will operate on the application of temperature.
So LED TVs use diode too.
Yes, light emitting diode. LED means light emitting diode. LDR means light detecting resistance or light dependent resistance. Or thermistors will operate on the application of temperature, right? So this
Yes,
thermistor will work on the concept of temperature. It will increase or decrease the value of electric current with respect to the temperature, right? Let's
yes.
suppose in some countries, in the street lamps on the road, they use thermocouple or thermistor in that street lamp, right? Because they will automatically operate during the daylight or during the night, right? Because in night we used to turn on those lamps or street lamps. So let's suppose if there is a manual connection, so if someone will turn on, so the lamp will light on, otherwise they will remain turned off. So if we use automatic diodes there like thermistors or thermocouples, so they will work on or with the reference of temperature, because in daylight the temperature is high, so the light will turn off automatically. They will detect the light. And in night, if they if we discuss about the temperature, so in daytime the temperature is high, so they operate with respect to the temperature, that if temperature is high, so there will be high resistance, so no current will flow through the circuit, right?
So
And
so these are used for street lights.
yes, I'm just giving a simple example of daily life application. They don't ask you about the detailed application or to write the complete procedure. And in night time, we need those lights to turn on. So when there is a low temperature, so there will be low resistance. So that will work on the concept of temperature with respect to resistance. So when there is low resistance, low temperature, so electricity will flow throughout the circuit. So that will light up the lamp, right?
Yes,
And if we talk about the LEDs, so LEDs are normally used in our devices nowadays, and LDRs are basically worked on the concept of light. They will be used for security purpose, just like we saw in the movies and in the videos that they used to make a laser light trap to save some vault or save some expensive uh, object over there. So they just produce a laser light trap that if someone crosses that light or just stop the path of those light, so alarm will automatically turn on, right? So they will work on the concept of LDRs, right?
Yes.
So these are some common applications which are related to diodes, right?